All right. So let me talk about what. Well, let me run some things and make sure the compiler works. Oh, I need to. Oh. So what I'm redoing, I'm rebuilding all the libraries that you link to, which, you know, in an actual compiler system, those would come pre-installed, but I don't have like an official, those don't go into source control right now. Or they do, but they only go in that directory, I guess. So I didn't officially have to remake them, I just had to recopy them, but I rebuilt them anyway. All right, so let's see what happens. BC, x64, debug. Okay, program runs. Okay, that runs. And it does some things. I didn't stream the latest version of this little test program, but it all works, and that makes me happy. Compile time and runtime. And so now let's try it on the little aliens. No, this. Yeah, that's what I was working on. Okay, so let me comment this out for a second to show you or make sure that the program works still. It's never a given. Whoops. Yeah. Let me put this in C++ mode. All right. Hey, look. Okay, so this is running at compile time right now. And I don't know who was here on the stream where we actually put gameplay in, but there's waves of these guys now. And when I clear out the wave, more will come. And you know what? I wanted to test the C version anyways, because that has a better frame rate. So now that it's compiled, that was all compile time program execution, right? For those of you who didn't see this necessarily. And now I'm going to run the whole program again, but the compiled version. All right. So let's make sure. I just want to make sure everything works, because like I said, it's very easy to sort of, oh, it works on this machine because something isn't checked in, or even some machine-specific thing. All right. So I don't want to pick up more bullets, because if I pick up more bullets, it'll reset me back to one bullet. So terrible. All right. Anyway, it works. So the thing that I was doing was, in C and C++, you have function pointers, which is how, if you want to put a function in a variable or on a struct, it's the thing that you do to make that happen. And so I don't have that facility yet, and I was in the middle of doing it this morning when it was time to go to real job and work on the witness. So I want to at least get that a little bit further, if not, I at least want to think about it, and I can talk about what I'm thinking about on the stream, and then we'll see if I do something about it. So anyway, I want to be able to have a member like this, right? So, this is a pointer that's null, and this is something else, and this is a function that takes a pointer to an invader and returns void. And this is just going to be like a function that you can stick on a guy, and he'll just call that function every frame, and he'll do whatever behavior that does, right? Because we don't have object and method type stuff yet, if ever we have that, it's not clear. You pass this guy, right, to his own update function, which is really what an object method does anyway. Like the pointer to the object is generally the implicit first argument to that kind of function. Someone's asking me, what am I hoping to achieve with this new language? There's like 4 hours of introductory lecture on that. You can go on YouTube and check it out. Yes, Edmund did a lot of the character design and animations for Braid, and they got revised later to fit, David Hellman did revisions on those and extra in between frames and helped them fit the style of the game that David did for the backgrounds. But no, Edmund's work is totally, if you know his character style, you can see it underneath the paint over. Um, I don't know how Go does struct methods, so I can't say if these are like it or not. Um, these are just like function pointers in C and C++. Now it's weird to think of them as function pointers though, because you can't like dereference a function pointer and do anything with that, right? So what it's a function is really all it is. It's just you're not copying the function body. The idea that it's a function pointer just is an implementation detail that tells you something about how much size it takes on the struct, right? But from a C level thing, it's like there's not much you can do with that pointer except call it or store it in another variable. So it's not really a full-on pointer the way pointers to data are. Anyway, so I don't remember why this didn't work. I do remember that maybe I was going to fix it directly and then clean something up, or maybe I was going to clean something up. Because sometimes if you fix a problem, but the problem was implicit in the, I don't know. So I want to investigate what's happening a little bit more, and then we'll clean up. So undeclared identifier, right? So what is happening is in this argument list, for some reason, it thinks it doesn't know what this is a pointer to. And I don't know. I don't think that that's because it's in a struct. Because if I do this, I can say like other invader star. And unless I broke that, that was in one of my early tests. Wow. Okay. That may be why. I have broken some things. Right. This is interesting. It's an interesting problem. So let me talk about what's going on here generally. This may even be two separate problems, but this one's more basic, so I got to solve this. This compiler doesn't have header files, right? So there's sort of a pipeline that your code goes through because the compiler works really hard to like put it together and put all the references together and make sure everything is processed correctly, right? In a language where you have type inference and you can refer to identifiers from other files that the compiler doesn't know yet, it can't just go straight in order like it does in something like C. And you don't want it to, because C and C++ create a great deal of agony for programmers because they require things in order like that, right? So everything in the language was working hunky-dory like that. But over the last week, I've been cleaning up a lot of things, and one of the things I did is sort of changed around the pipeline that variable declarations go through. And I never tried anything in a struct containing a pointer to that type of struct, which was in my initial tests. That worked in my original demo. In fact, I showed some structs that do that. Here, it thinks there's a circular dependency because it thinks, oh, to know the size of this invader struct, I need to know the sizes of everything and add them together, right? Oh, but to know the size of this thing, I need to know what the size of an invader pointer is, and that depends on what size an invader is. Well, actually, it doesn't, right? If I did this, that would be a full-on circular dependency, and there's no way you can't, in any programming language, you can't really say what this is because, if you make this bigger, this gets bigger, and then that gets bigger. This is like a recursive explosion, right? But a pointer is always the same size. So this thing, for bytecode sizing purposes, should not care if there's a pointer what the size of that pointer is. Yeah, Graphite Master is explaining it correctly in the chat, right? All pointers are the same size, or that's actually not necessarily true because you might have fat pointers or something that bring other, like an array pointer might have like a pointer to the data and a number of items, right? like Go does that, I think, or something. But or D does that. I don't know. Anyway, I'm probably going to do that here. So different pointer types might be different sizes, but they're a known size. Like you don't need to know the details of what's inside. So what happens is I need to go Jimmy with the dependency system now. The reason this used to not be a problem is because I didn't used to put a dependency between this and these, because the way the compiler worked was when it got to a struct, it said, okay, just in a tight loop in the bytecode system, I'm going to go through every item in the struct and just see how big they are, and then add all that up, and then do this. So there was no like dependency explicitly. There was just code that did it, right? But that relied on being able to process every member of a struct in order at once, which was normally fine because, you know, if you depend, like I said, you could depend on something like a bitmap that, say this was defined in another file and you hadn't got to it yet, that would all work fine because Invader would end up with a dependency on bitmap and you'd wait to process all of this at once till you could. But the reason I changed it, and the reason I consider the compiler more robust now, is because I want to get the stage set for namespaces, right? And I want structs and namespaces to be basically the same thing. And a namespace could be really big, and it could span multiple files, and it could have things that otherwise would look like a little like circular dependencies like in them. So I felt like the requirement to handle a namespace all at once in one tight loop of code would have been impossible. And it would have been weird because like everything in a namespace really ought to be kind of at top level. So basically I rewrote all the struct handling and all the namespace handling to treat each of these individually. So what happens is each of these guys lives off in the dependency queue processor by himself, and as each of these clears, then he gets registered with the struct, and then this guy just has dependencies on all these guys, and when all those dependencies are cleared, then we can compute the size of this. But the dependencies only go in that direction in bytecode, right? Because to generate the bytecode, the first pass is sizing, right? And that's why it's saying bytecode builder couldn't resolve these, right? And it's giving me a big list. I should sort this list at some point, because if it's sorted, it's very easy to tell who's causing the problem. You know, I don't, again, this is a thing about making error messages good that I don't necessarily need. For when there are real users of this programming language, I need to care tremendously. But for now, I don't care that much because I usually know what's going on. You know, I sort of use how much I'm confused about the situation to drive which parts of the compiler that I work on. Anyway, so if you look at all these who depends on who here, you'll find that well, actually, it's not even listing capital I invaders, and I think the reason is just because it's in a different queue. I need to print out both queues. This is probably the code generation queue, and all these guys are stalled in the code generation queue because this struct is not passing the sizing queue. Do structures maintain their layout in memory as declared in the source text? Yes, they do. They get processed in an arbitrary order, but they'll get laid out in memory in a known order. So you can look at the program text and know exactly, where things are, and I think that's very important for a low-level language. High-level, low-level language. Okay, so the way this works, I'm going to fiddle around and try and fix this. And the way these dependencies get added is they just start out as you look for what identifiers get used in a declaration, and then you just blindly put those on that declaration, right? So this invader dependency gets put on here very early in the pipeline. So what I think I'm going to do is later in the pipeline during type inference, when if I have a declaration, actually if I infer a type, then I have a function that'll recurse and give me all identifiers that refer to external definitions. That's something that I use for other things. So, when I declare a pointer to something, I can then just look in that subtree of code and remove all dependencies from that. But I'm actually not sure that we want to do that, because that might be overzealous. Because what if... Oh no, just for the purposes of sizing, right? Just for the purposes of sizing, it's fine, I think. That's my theory. So that's what I'm going to... Does anyone have questions about that? That's what I'm going to do for about 20, 25 minutes. I probably won't successfully do it because it's actually a little bit complicated. And it's not even necessarily the best way to solve it, but I don't know that I can think of a better way to solve it. Is this going to be posted on YouTube? Maybe. I forgot to split the stream. So we'll see. A lot of live stream things get posted to YouTube. Well, if you want to reorder structured data, that could be a feature that the language provides, but it shouldn't do that unless you tell it to, right? So the compiler certainly should have the capability to lay things out exactly like you say. And yeah, and in fact, if you were to do profile guided layout, which I'm not even sure if that's ever a good idea, but if you were to do that, I think the best way to do that is try some things and then just say, if certain platform, lay it out like this. I don't think you want weird struct variants laying around in some database somewhere. That's weird. I don't know. Oh, we already did witness poster making. Let me change this. Compiler programming. Sorry, you missed it. How far am I into the compiler? Yeah, you generally want to have some real code, so that's where I'm at. How far am I compared to all the work that needs to be done? Not necessarily that far. Like I said in one of the talks, we have a language that is suitable for prototyping and playing around with. I would never recommend that somebody ship a game in this yet and try to sell it to anyone, because they'll have a lot of problems. Like I said, the thing is not even feature complete yet. You can't even have a function on a struct and call it yet. It's coming soon, but one step at a time. What my stance is on strict aliasing, I don't know, dude. Anything that'll help us generate better code is good. The problem is, if you use a keyword like restrict or something like that, then you'd really better be sure that you're right. And if you get it wrong, you may not realize you get it wrong, because the bug that you introduce may get triggered very, very rarely. So keywords like restrict are actually very dangerous unless you have a way for the compiler to back you up on that. And what I'm interested in is maybe somehow declaring things like, look, nobody else is ever going to touch this memory but me, right? Or something like that. You know how Rust sort of has a borrow checker that checks some things? I don't want to do all that because that's complicated and weird, but I might have a thing where you say look, this pointer on this struct, I don't know, maybe I use exclamation point for something else, but you use some syntax that says nobody else can actually alias any of this memory through this pointer. It only gets referenced through this pointer. And any other aliasing is a compile time error. That would be a very simple, very straightforward thing, and it doesn't rely on you annotating function parameters in weird ways. So maybe this is where restrict goes, right? And if you put restrict, it means that all you can do is take R values out of here, right? You can't take an L value to anywhere in this memory. Something like that would be better. But I haven't thought about it too seriously. It's not like trying to use restrict in code is not my jam lately. Like I've been writing a lot of gameplay code lately, so yeah. Aliasing data as a different type. I don't know, whatever. It's all the same. Eh. I think you want to do type punning. You want that capability, but it should also be obvious to the compiler when you're doing it. So like putting something into a union and pulling it out as another type is a pretty good way to do that, I think. That said, you need people to be able to do unsafe, like this is just random memory that the compiler doesn't even understand. And so, you know, this will all work. How do I balance interesting, self-indulgent personal projects with other work? I don't do self-indulgent personal projects. Um, memcopy is type punning. Like that's yeah. Anyway, let me try and do some work here. I'm going to be done before 8 because, of course, Handmade Hero comes on at 8, and that'll be good. Anyway, so like I was saying, if I go into here and say, I'm just searching because the code is really big, so like hell if I know where is the thing that I'm looking for. Infer types. This seems like maybe the right function. Here we go. All right, so if we're doing type inference on a type definition, which is what, well, yeah. Go to the parser, definition. Right, so there's a bunch of stuff in here. Again, some of this is mutually exclusive. Sorry about the, I usually edit with many more columns, which is why the comments are all over the place. But for streaming purposes, I have the text all big. Like I've said before, some of this stuff is mutually exclusive, so ideally you want to union it, but it's easier for me in the debugger to just eye a big structure and see that most of it's 0 to tell what the hell's going on. So I actually leave it deunioned until much later in development. Anyway, when something is a pointer, then this pointer too is set, right? And this is a pointer to another type definition. So I'm looking for the place that does infer types on the pointer 2, which may not be here, which would be weird. Oh, it's at the very end. Yeah. Okay, so this type definition will have already, during parse time, added dependencies based on whatever identifiers fall within the AST corresponding to defin pointer 2. We want to remove those dependencies from the sizing queue the code generation queue, right? You don't, to generate code for a pointer to something, you don't, yeah. We'll to do and the code generation queue, since we don't need them and they would generate incorrect circular dependencies. So, this is stuff that I wouldn't have to think about and work that I wouldn't have to do if I was just being like C. But, this is what making a good language is about, right? You work hard for the user, man. You fight for the user like Tron. If you could name integral values with numbers in them, what does that even mean? Name integral values with numbers in them. So, okay, so type inference is, the way that I use that phrase here, it sort of denotes two things, right? One, you figure out the type of something based on the type of what's around it. Like if you assign something to something else and you don't declare what type it should be, then it picks up the type from the R value, the thing on the right, right? But also, the other part of this is just the compiler sort of hardening its notion of what every type is, which is maybe something that you would do without type inference or with a much weaker type inference. So, if you said something is an integer of some size and it's 513, right? Then that could be a 2-byte integer, right? And just the compiler decides, by the end of this pass, the compiler decides all that stuff, like what type everything is, and the type of nothing can change after this pass, right? It's not exactly a pass because, like I said, people stream through here, so the whole program doesn't go through here at the same time. But it's a sweep, something like that. It's a sweep. All right, wow, I'm going to get nothing done while I talk. But, I'm in a slow mood today, so whatever. All right, so I have some function that collects identifiers, and I don't even know where it is. What else did I use it for? See, when a program is complicated enough that, see, after I've worked with something for like a year, okay, here we go, get depending idents. Like I sort of know what I name things, but there's a lot of things called idents, so who knows. All right, so this is a thing. Oh, this is a set of functions, right, that recurse through the AST of the program. Right, okay. I don't actually use this for its original purpose anymore, I don't think. Oh, I do for return value. Okay. Do I have a special problem with... No, I don't. Okay. So, when I'm parsing a return type to a function, for example, like here, you want the function header or the function itself to depend on all the dependencies of the return type. The return type isn't a declaration of its own that lives in the global space. So what I do is I reach into that subset of the syntax tree, grab all the identifiers that represent things we need to depend on, and then put those I basically do this thing that I'm about to do now, where I pull those identifiers off whatever they think they depend on, right? And I put them on the function header. So I need to do the same operation. I should probably name it at some point, but I'm not going to do that yet. I'm just going to copy and paste the code because it's always what I do, and then I formalize it later if it really is the same operation. So So if it's a pointer, right, I want to get the depending idents inside the pointer. And, you know, this should live down here because put it where you use it. You know, sometimes as you edit code, declarations drift away from the things that use them and stuff. Like maybe I was using that up. In fact, I was using that for arguments, and now I'm not using it for arguments anymore, so it can go down. Like, you know, it's part of little micro motions like this are part of keeping your code clean. I didn't mute myself for that. Okay. So we're going to get those identifiers that we depend on, and we're going to transplant them. And I'm going to put this as something that's searchable. So later, if I want to clean this up, I just search for this @transplant thing, and I'll see who does this and what is happening. So here's the trick, though. Let me see. So I need to make this callable, and I'm just going to paste this. This is how instead of putting stuff in header files, if they're not widely used, if they're just used once or twice, I'll actually paste the prototype, or what is this? I never remember if this is a declaration or a definition. Halfway, because Visual C++ freaking gets confused between those two things all the time when I try to skip to them. So I believe this is a declaration, right? And the definition is the actual body, but whatever. Okay, so I get those. I remove them from the thing, but I don't actually put them anywhere. We don't put these anywhere new. We just don't depend on them at all. Okay. I don't actually want to wait this far, I don't think, to do this. Because I don't need to. And because this might, you know, I'm thinking this might actually, even though I didn't see that dependency, that circular dependency till bytecode, it might also happen in type inference. And so I have all this information at parse time, right? As soon as I've parsed something and say, oh, it's a pointer, then I've got that. So I'm actually going to take this out of here and go into the parser. I'll make this static again because we're in the parser still. And I'm going to say, do I have a parse type? Parse, I guess it's parse type instantiation. Parse type instantiation. Okay. So we are a pointer. Congratulations. However, let's remove any dependencies we may have developed because we don't need them for a pointer. So now, I'm actually not sure. The reason why this may end up being a big job is because I don't have a clear picture in my head of what will happen, for example, during type inference, if I haven't wandered this whole subtree and actually inferred types on it. In theory, I don't need to, but there might be some code that's unhappy about that. So, you know, there might have been some code that relied upon the fact that I was recursing down the type and doing some things to it even though I don't necessarily need to. And that code may need to get fixed and stuff. So okay, this is a better place to put it than where I was about to put it. I don't need this because it's up in the earlier in this file now. Octal prefix is terrible. I accidentally did a bug once because I put a leading 0 on something to be cute, and oh my god, I was so angry. There will be no leading 0 octal in this language, I guarantee you that. Like, what's wrong with putting 0C or 0O, right? Like, if 0x is your hex, like, just be consistent, for God's sake. I mean, octal, you probably wrote octal numbers on the PDP 8 as like 4-digit 0 leading. I don't know. Okay. Leading 0. Look, if your printf function prints something out, then when you parse it back, you should get the same thing, right? If you print up a decimal in leading zeros, you should be able to pass it to something, and it parses it as decimal. Yeah, I don't know. I don't know if I care about prefix or suffix. That's just an implementation detail. Prefix makes the lexer a little bit easier, I guess. Especially for big numbers. Yeah. I think with a suffix you might have to be 2-pass. It's a little bit sad. Okay. So I believe this probably works. Let me look at this again. So it just basically grabs all identifiers, that were listed as unresolved, and it doesn't care about anything else. Okay, I honestly don't know what this is going to do exactly, but that's my life with this compiler. It's complicated enough and new enough to me that I often just don't. Oh, wait, I was using that up there. Oh, but it's empty. Wait. Should I just pass null for this? Wait, I'm still... Oh, right, okay. So I was confused. When I said I changed the code to make all declarations flow through separately, I do, except declarations of function parameters don't flow separately because there's no reason to make them separate, I don't think. Like, they're still treated as part of the function header and happen in line with that. So everything else is. All right, so right, this is called type def here, or pointer. I have both names for it, right? So pointer. All right, let's see if this even doesn't crash. Whoa, okay, so yeah, I think the code didn't like my not doing that. There's like at least, well, I don't know. I'll take it one error at a time. So undeclared identifier in type declaration. That is odd. Let's see where it says this is happening. In type declaration event in GL line 50. So yeah, it's saying event is an undeclared identifier because we're not looking it up, right? Like whoever looks for undeclared identifiers is mad that we didn't resolve this. But the truth is, we shouldn't. Well, okay, this is a little hairy because we do need to actually resolve it eventually. So it's not as simple as I was saying. The reason we need to resolve it eventually is because we need to type check this against things that are the same type, but things of the same type don't necessarily always have the same name. Like you could alias something into your namespace or whatever. Like, so honestly, I may have been right about putting it in the previous place after type inference. Is that going to work? Yes, it's gonna work, I think. You know what? This is entertaining. All right, so let's comment all that out and leave it there in case we want to come back to it. Let's go back to Let's go back to where I put it the first time and undelete it. Thank you, Emacs, for remembering what I did. So actually, I didn't undelete that. I just typed it all really fast because I typed faster than Casey. Okay. Let's see what happens when we do it here. Probably something different. Okay. We get the same complaint, which maybe just, oh, right, because, okay. Okay. So removing this here isn't enough at this point. We have to actually go in, because by the time we get here through type inference, the person who we're making depend on this may have also gone through type inference. And in fact, it's likely. So I need to go remove him from all these. I'll show you what the pipeline stages look like. So basically this thing called dependency pipe where you pass through these things in sequence. So first you get your identifiers resolved, then you get your types inferred, then you get sized, then you get bytecode built, and provided that all that succeeded, and maybe you've even run some things in the middle because hash runs happen during bytecode build, eventually we may output some C code. So all declarations pass through this 5-stage thing. And if you saw during some of my earlier live streams how I was saying, oh, I'm just going to cut and paste all this pipelining stuff, I have since cleaned that up and wrapped that into this one place that gets centrally called. And it's a good thing that I waited because it came out cleaner this way because I knew really what I was doing by the time I did that. So really what happens is I'm just going to remove from the dependency from to size and to build. And maybe to output C, but I don't think we put one there. So to size dot remove. Wait. Yeah. That's not the right thing. Well, those are the dependency pipes, but that's not what I need to remove something from. What I need to remove something from is every declaration. This is a relatively inefficient way to store things, but it's easy for debugging. Every declaration gets an array of the kinds of dependencies it has. So if I'm going to size something, here are the people who need to be sized before me, right? If I'm going to build bytecode, here are the people that need to be built before me. And so these are the things that I need to remove the guy from. I say this is inefficient because it's like 4 arrays that get dynamically allocated that probably have a few elements each most of the time. It's probably better to just have one array and like to put people inside and then tag them as to what kind. So you might have a general dependencies array and say, this is a build dependency, this is a size dependency. I suspect that would be faster. Maybe not. I don't know. But for now, it's easier for me to just look in debug information that's set up this way. So I'm going to say I'm going to put removed here. I'm not going to use it, but again, I can step in the debugger and see what the return value was and make sure it got removed. It size dependencies. Do I want it? No, I want auto decal it listed as unresolved within. That's the declaration, right? I should have just, yeah. So removed is it decal declaration size dependencies dot remove it that identify. Wait. It resolved what's it called? Resolved declaration. If I had, so what that is by the time we get to this part of the pipeline, this identifier, so we're going through an array of identifiers, and here we just removed it in case anybody is early in the pipeline. But if they're later in the pipeline, then this identifier has been matched to a declaration by now. I assume. I don't know. Maybe that's not a correct assumption. So I'm going to remove it from the size dependencies and the build dependencies, and get depending idents is no longer, oh, because, right, because I made it static. Okay. Okay, let's see what happens. This is going to be about the last thing I do, because I'm going to, hey, look! Oh my god, it compiled. I fixed it in the last minute. Well, let's see if it gets through the C phase. It didn't get through the C phase. So I guess there's a C dependency. No, okay. No, this is fine. It generated C code. This is the C compiler complaining. So that's a separate bug that I need to look into, but I actually fixed the bug that I aimed to fix while doing it very slowly and talking verbosely. So I'm going to sign you guys over. I'll take questions for 1 minute or something.